Okay, welcome to the podcast about the graphs of secant and cosecant. Okay, so we're going to start with secant theta, and you may notice that on this graph here that I already have made is a picture of a different graph. This is not the graph of secant yet, right? What is it the graph of? If you look at it, it's a sinusoid, and if I can look at it carefully, it has the standard amplitude of 1. It has its peak right here at 1. So this is telling me that this is a cosine graph because it's at its maximum at 0 degrees. So this is the graph of y equals cosine theta. Now, why would I graph cosine theta if ultimately what I want to do is graph secant theta? Well, because cosine and secant have a special relationship, right? I know that cosine of theta is equal to u over r, and secant theta is r over u. So another way that I can write that is that secant theta is equal to 1 over cosine of theta. So what that means is that if I know the cosine value for a particular angle, I can just do 1 over that number to get the secant value. And that'll help me figure out how I'm going to draw this graph. So the very first point that I want to plot is the point that corresponds to this point on the cosine graph, 0, 1. Okay, so at 0 degrees, the cosine value is 1. And I'm just going to make a little table here, right? So the angle, the cosine value, and then the secant value. Okay, so at 0 degrees, the cosine value is 1. So the secant value is 1 divided by 1, which is also 1. So at this very point here, right, I'm making a big dot here, the secant graph and the cosine graph are in the same place. Okay, so I know a couple things about what's going to be convenient here. So I'm going to choose some angles that you might not otherwise choose to figure out what the graph of secant is going to look like. The next angle I'm going to look at is going to be 60 degrees. Now, you guys have all been practicing the unit circle diligently, so you should know off the top of your head that the cosine of 60 degrees is 1/2. And even if you didn't know that, you could take a look at the graph, right? And you could see that this point right here, right, at 60 degrees has a y value of 1/2. So you didn't even really need to calculate that. You could have just read it off the graph. So the secant of theta is going to be 1 divided by 1/2. And if I do that, I get 2. Okay? So 2 is right here. So it looks like secant is going up. Okay, so I'm going to look at 90 degrees next. At 90 degrees, you can read right off of the graph here that cosine of 90 is 0. You also know that from the unit circle. Secant of 90 degrees is then 1 over 0, which is undefined. What does that mean for the graph? Well, I got to think about this a little bit more carefully. So as I go from 60 to 90 degrees on the cosine graph, the cosine value gets smaller, smaller, smaller. So if I think about what happens is I divide 1 by a smaller and smaller fraction, I get a bigger and bigger answer. Like 1 divided by 1/2 is 2. 1 divided by 1/3 is 3. 1 divided by 1/10 is 10. 1 divided by 1/100th is 100. Do you see what's happening? So as I go along the cosine graph from 60 degrees closer and closer and closer to 90 degrees, I'm getting all of these numbers here as my cosine values because cosine is getting smaller and smaller and smaller. So what's going to happen is that secant is going to get bigger and bigger and bigger without bound, right? When I'm really infinitely close to 90 degrees, you know, the cosine value might be 0.0000000000001, which would make the secant value be ginormous, right? So what's really going on here is I am getting a vertical asymptote. So I'm going to go ahead and draw this on here. Here's a vertical asymptote in the secant graph here at 90 degrees. And actually, while I'm at it, what I'm going to do right now is I'm going to go ahead and draw every other time that the cosine graph is equal to 0, the secant graph is going to have a vertical asymptote. So I'm going to go ahead and draw on vertical asymptotes here at 270, at 450, and also at -90. Okay, so there's vertical asymptotes in the secant graph at those points. And based on the other 2 points that I've already drawn, I can go ahead and kind of connect the dots here and say that secant is going to go up from there without bound. Okay, so let's try to figure out what the rest of this graph looks like. I'm going to kind of go to the left now, and I'm going to look at a couple more angles, right? And I'm going to say, well, what happens at negative 60 degrees, right? Well, at negative 60, cosine is still 1/2. So secant, we've already done that, is 2, right? So here, this point is going to happen, and I'm going to get the same thing reflected on the other side of the y-axis, just like I do with cosine, right? Cosine is symmetric around the y-axis, so is secant. Now let's look at the section between 90 and 270 degrees here. Well, let's start with 180. At 180 degrees, the cosine value is -1. 1 divided by -1 is still -1. So here, I'm going to get that same point. Now, what do you suppose is going to happen, right? Cosine is negative this whole time, right? Between 90 and 270, right? Cosine's negative. So secant is going to be 1 over a negative number, which is also a negative number. And I know that I'm going to get vertical asymptotes at 90 and at 270 because we already figured that out. So what's going to happen? It's going to go down like this. Now, if you wanted to draw more critical points, good choices would be 120 and 240, because again, those are places where cosine is equal to 1/2, so secant is going to be equal to 2. But in general, we can only consider the critical points for a secant graph to be the points where it comes up and kisses the cosine graph, right? Like these little smooches right here at 0 degrees and at 180 degrees. Those are part of the critical points for secant, and so are the asymptotes. So for instance, if I wanted to draw the section of the secant graph between 270 and 450, I'm just going to draw here at 300 degrees when cosine is equal to 1, secant is also equal to 1. That's the critical point, and then I'm just going to draw the secant graph going up to infinity towards the asymptotes. And I'll draw the last 2 sections here, right? That's going to be there. And this is going to be here. So this is what the secant graph looks like. Now remember that the green part is not the secant graph. The only part here that is the secant graph is what I've drawn in blue. So the blue is y equals secant theta. And actually, just to clarify, the green is not secant, right? The blue is secant. The green is not secant. Okay, that's all there is for secant theta. It makes a lot of sense, I hope. And what we're going to do now is we're going to look at the same thing for cosecant. Okay. Okay, so here is a graph of sine theta, and I want to draw the graph of cosecant theta. And what I'm going to do is use what I learned when I drew the secant graph to draw the cosecant graph. I know that cosecant of theta is 1 over sine theta, just like secant theta is 1 over cosine theta. So I know that when sine theta is equal to 0, I'm going to get a vertical asymptote. So I'm going to go ahead and draw those vertical asymptotes on the graph. Right, those are my vertical asymptotes. And I know that when the graph is equal to +1 or -1, for sine theta, that the cosecant graph is going to be the same thing, right? In other words, these are the places where the cosecant graph kisses the sine graph. And now all I'm going to do is just draw on the little U shapes, right? This is what the graph of cosecant looks like. Awesome. That's the whole story. Now, one thing I want to do is just have you think about what's the difference between the secant graph and the cosecant graph. So this is the cosecant graph, right? It looks awfully similar to the secant graph that we drew a minute ago, right? So the only difference between the secant graph and the cosecant graph is that the secant graph is translated 90 degrees to the right, or sorry, the secant graph is 90 degrees to the left of the cosecant graph, just like cosine is 90 degrees to the left of sine. So the relationship that I have between sine and cosine directly mirrors the relationship that I have between secant and cosecant. Okay, that's all there is to know about secant and cosecant graphs.